'cause you're a good girl, you know it. And I know exactly who you could be. Just hold on, we're going home.
Alright, here we go, starting off a little Drake to get us going here. 10.2, multiply and divide, rational expressions. Pretty excited here. For those of you who are, pretty savvy with the music, that wasn't Drake. I don't know if I tricked you on that one. That was actually one of my favorite artists, JJ Icefish, so that was pretty sweet. So, if you look at this Drake cover, there's Drake over here, here's Mr. Brust, or if I was a rapper, I'd probably be B Rizzle. I always thought that'd be a pretty good rap name if the math thing doesn't pan out for me. Nothing was the same. Why is nothing the same, Drake? Well, what's he thinking about in that cover? I always wonder what he's thinking about. There's what he's thinking about. He's thinking about a division problem. And, I didn't know that. And what's Mr. Brust thinking about? Oh, a multiplication. So here's some rational expressions that we're going to simplify. And I think Drake's right. Now we know it. Once you know how to do this, nothing is the same, Drake. Nailed it. Awesome. So let's take a look at this. We're going to start off first just by simplifying. So I want to make sure we can simplify these before we get into multiplying and dividing them. So we're going to start this off old school style. What if you just had a fraction? Remember, if I just wanted to reduce a fraction, you're looking for okay, what's the biggest number divides both of these? Well, I think what we can say 4 divides both of them. 4 goes into this 5 times. 4 goes into this 6 times. And we've reduced the fraction to 5, 6. So that's what we're doing. We're doing the same thing here. 4 sevenths doesn't reduce, but can I cancel some things out here? Like I canceled the 4's out of there. Sure, you can cancel the x's out of this and you're left with just 4 sevenths. Awesome. So it's just like we're simplifying fractions. Now I'm putting some variables in there. When we do that, though, we have to be careful with excluded values. There are values that are excluded, but you can't say excluded because that's in the definition or the word. So they're left out. So in this case, I have to say that x is not allowed to equal 0. Why can't x equal 0 in my original here? Well, if I did, then you'd be dividing by 0. We can't do that. Remember, that's a vertical asymptote. So even though I cross it out, yeah, that's great to reduce it. I have to say, okay, x can't equal 0. So before I really start these, if I look over here at the next example, I got to say what? This is cool, but x can't equal 4 or -3 because that would make the bottom 0. The reason that's important, because check this out. Does anything cancel? Sure. This cancels this. Only because it's around multiplication can we do that. We can cancel around multiplication. So this is 4 over x minus 4. So even though in my simplified version, yeah, I see x can't be 4, but x can't also be -3 even in this simplified form. You would never know that, so we got to make sure we address the excluded values here. Awesome. So how about this? What if I have a c and bc? It's just, that's the formal, I think, definition of this. You're left with a over b. How about this bad boy here? Can I just, a lot of people love to do this right here. They love to say, oh yeah, well 2x cancels 4x twice, 1 and 3. Awesome, that's great. Can't do that. That's a huge no-no. Please don't ever do that. No, that's a common mistake. You can't do it because it's around these addition signs and subtractions. You can't take part of it. It's all or nothing. So if it's multiplication, you can do it, but you can't take pieces around addition or subtraction. So that's actually simplified. You're done. Done and done. If you want to think about the excluded values in this case, you have to solve it. Set the bottom equal to 0, and you're looking at what? That's x equals 9 halves here. Awesome. So all you can do is find the excluded value for that one. Cool. So that's simplifying. Can we do this? Sure. Sometimes when we simplify before we start, though, what do we got to do? Well, we got to factor. I can break down this bottom. This is a difference of squares to x plus 4, x minus 4. I wrote that backwards and I said it. No worries. Now, where the excluded values, yeah, you can say x cannot be 4 or -4 because that would give you 0 on the bottom. The reason I factored is anything cancel now after I factored it. Sure. Boom. Boom, that cancels the top. And again, that's like it's in parentheses, so it's okay. This is all multiplication. So I'm left with what? 1 on top, x minus 4 on bottom. Awesome. Very nice. Can I simplify this bad boy over here? I hope so. So I can't really look at this and tell you the excluded values, but if I factor it, what multiplies to 24, adds or subtracts to 2, I'm going to guess it's -6 plus 4. I hope that's right. So my excluded values are p cannot equal what makes this 0. Because remember, this is around multiplication. If you put 6 in here, 6 minus 6 is 0. 0 times anything is 0. So 6 is a problem for us. And -4 makes this one 0. Does the top factor? Well, yeah, I can say what number divides both of these. I'm going to pull out the greatest common factor, or undistribute. Pull out that 2. And they both have a p in common. So I can actually pull out a 2p. And I'm left with what's in here. If I undistribute, 2p squared divided by 2p is just left with that p. Minus 12p divided by that is 6. Awesome. So I factored that out, and what's good about that? Sweet. This cancels. This cancels. That sounds a little bit like Candy Crush. Sweet.
Sweet.
I like that. So we got 2p over p plus 4. Excellent. That's supposed to be a p right there. Very good. So we're simplifying it. Nice. So now we can simplify. Let's go ahead and start doing what we're supposed to do here. We're supposed to multiply and divide, and it's kind of some of the same idea. So now I've got a multiplication problem. So this is a rational expression here that I'm multiplying them. And again, this is just this is all multiplication, so we can just start canceling. So let's start with the numbers. 3 goes into 9 3 times, so I'm left with that. 2 goes into 4 twice, so those numbers canceled out. Let's start canceling some x's. This x cancels one of these, 2, so I'm left with 1. Remember, if you want, you can think of this as x squared as xx, so I canceled one of them. Oh, there's another x. I'm going to cancel out that other one, or you can think of that being gone. This y is going to cancel out one of those. This is what I usually do. Instead of right now, I usually just change that to I have 2 y's. But if you want to write out y and cancel it out, that's cool. So really, what am I left with here? I'm left with on top, I don't think anything else cancels on top, 2 times 3 times y squared. So that's 6y squared. All over that just disappeared is x on bottom, so I'm left with that. Very nice. So there's my answer. I'm not going to worry about excluded values on these. That's just for simplifying. But later on, we'll come back to the excluded values. We'll come up at 10.4, so pretty important. Awesome. Very nice. Moving on here. So again, now I got a little trickier. I have to do a little factoring first. So hopefully this factors out a little bit. So what adds to 7 multiplies to 12? It should be x plus 3, x plus 4. Ooh, we got a difference of squares here. So they're both perfect squares, 5 times 5, so we'll do this. On top, that's already done, deal, and over here, it looks like I can pull 3 out, undistribute. So I've kind of got all types of factoring going on up here. Hopefully some things will start to cancel here. So if I look at this, x plus 3 cancels x plus 3. Anything else? X plus 5 cancels x plus 5. That's it. That looks like it's it. So on top, everything canceled except for the 3. So we got the 3 on top. On bottom, I've got x plus 4. And x minus 5. If you want to multiply that out, you are more than welcome to multiply that out. I'm going to leave them just like that, though. I'm going to leave it like that. I'm not going to spend time doing that. So factored form is cool. Awesome. What about if there's I've got a fraction. This is not a fraction over here. Well, technically everything in the world is a fraction, right? It's just being divided by 1. So really, yes, this is a fraction. So again, let's factor this out. What comes out of here? It looks like I can pull a 2n out, and what's left, 4n squared divided by 2n is 2n plus 1. So you're pulling out that greatest common factor. Does this factor over here? Yes, you're thinking about what multiplies. Remember, you got to do this. Because I got a leading coefficient, I'm looking for what multiplies to negative 6, adds to negative 5. To me, it looks like what? It looks like, I'm going to say, negative 6 and positive 1. So when I do this, I go ahead and write this out. I say, sure, if I'm going to come over here, bring that 2 into both of them. So this is kind of our little cheat method. This is 2x minus 6. And then I've got 2x plus 1. But this can't be right. There's no way you could FOIL that or distribute that back to get to this because 2 is the first one. So remember, I multiplied it by this, 3 times 2. So I got to get that 2 out of there. I got to undo that 2. So here it is. These both have 2 in it. So I kind of got to, I guess it's reducing. It's pretty shady, but you're dividing that 2 out. You get x minus 3. Nothing comes out of this one. So that is the factored form here. So that is not the factored form. That's just a step to get there. So really, I'm looking at x minus 3 times 2x plus 1. Fantastic. Now do things start canceling? So a lot of factoring going on. I changed it to x. Really, what should this be in? No worries, you can change them all to x, but since I was using n, I better go back and call these n's. Call them whatever you want, but just be consistent all the way through. So I'm going to go to n's here. Does it cancel? Yes. Here we go. We've got 2n plus 1 cancels this 2n plus 1. Does anything else cancel? No, it doesn't. So this is really going to equal n minus 3 is on top times n minus 3 all over what's on bottom, 2n, and then the 1, so we're left with 2n. This one I may simplify if I really want to. You could call it n minus 3 squared, but I'm not too worried about that. I'm worried about the canceling. If you want to leave it all completely factored, leave it all factored. I'm cool with that. That is multiplication. Boom, nailed it. Moving on to division. So, remember what happens when you divide fractions. What are you really doing when you're dividing? Well, you're flipping the second fraction and multiplying. So flip that bad boy over. You've got 15 over 6x. So first thing you gotta do, rewrite it as a multiplication. So division is just multiplication, flip the second fraction. Hopefully some things cancel. Sure, my x is gonna cancel my x. I've got this 3 goes into that once, 3 goes into 6 2 times, 5 goes into itself once, 5 goes into that 3 times. Alright, so we'll go ahead and multiply across the top. We get 1 times 3 is 3, and then on bottom we have x squared times 2 is 2x squared. Fantastic. Be great for us. How about this one here? So I've got this fraction. So the first fraction I leave the same here. Flip that second fraction over and multiply. So we're going to have m squared minus 4 over 3 times m plus 5. So I'm not going to distribute that because my goal is to have it factored so things canceled. So let's start factoring this. That's good to go. M squared minus 4 is m plus 2 m minus 2, so a lot of difference in squares here. This actually factors on bottom. 2 minus m, you know, if we change the order of this, this is really negative m plus 2. So this looks a little bit better. Does it cancel that m plus 2? No, because it's negative m. You know, it's like in parentheses, this whole thing. So it doesn't. But I can pull a negative out of this. You can undistribute a negative 1, and what's left? Well, divide out negative 1, you're left with m. You've got a positive 2, you divide the negative out, it changes its sign. So actually, 2 minus m equals negative m plus 2 equals negative 1 times m minus 2. If I distribute that back out, I'm up to here. Why did I do all that work? Well, that is factored. Now look at this. Let's start canceling. I can say m minus 2 cancels m minus 2. Awesome. M plus 5, m plus 5. So I'm left with negative 1 times 3 on bottom. So I'm left with negative 3's on bottom. Anything left on top? Sure, m plus 2. So it's just a matter of keeping it organized. Mine's nice because I have a lot of different colors. Maybe you want to get some colored pencils. I don't know. How about this? Again, this is that case where everything is a fraction. So it is over 1. So I'm really looking at y minus 4. The first one stays the same. You have to rewrite it. Flip that bad boy over. Can I flip it and factor at the same time? I'm going to go for it. Let's do it. I hope that's not too crazy. What am I saying? What multiplies to 36? I'm thinking it's going to be plus 9. And y minus 4. And does anything cancel here? It's looking pretty good. Here's my y minus 4, y minus 4. I'm nothing but 1 on top, so 1 times 1 is 1. On bottom, I'm looking at y plus 5 in parentheses times y plus 9. Boom. That's pretty sweet.
Sweet.
All right, here we go. Moving on. So we did multiplication, division. Here's another type of division. It's gonna lead us into the whole realm of complex fractions. So a complex fraction in this case means a fraction in a fraction. We've got a fraction divided by a fraction. Really, we've done these. It just means this. It's another way of writing this. But sometimes we're gonna have fractions and fractions. So if I had this, what would you do? You'd flip the second fraction and multiply. So what are we gonna do? We're gonna flip that bottom fraction and multiply. So we're really saying it's 1/3 times flip that over 4/3. Flip the bottom fraction and multiply. So when I do that, I'm left with 4/9. Nothing canceled in that case. Awesome. So again, this division bar, I mean all these mean division, but this fraction bar is division. So what do? I have x minus x over 4. I'm going to flip the bottom fraction, so it's 5 over 2x and multiply. Does anything cancel? Oh yeah, we've got these x's canceling. I think that's it for numbers. We're looking at 5/8. So those are kind of not too bad. Check this bad boy out. So again, I'm going to take that top fraction and just rewrite it. I'm going to multiply by flip this bad boy over, flip the fraction. So I'm looking at 9 over x squared minus 4. Do I get anything to cancel? Well, let's factor. Boom, another difference of squares right here. I love it. I got to factor all day long. This is awesome. So here we go. X plus 2 on top cancels this x plus 2. The 3 goes into itself once, goes into that 3 times. I'm looking at on top 1 times 3 is 3. On bottom, x minus 2. Fantastic. I have one more here. Not sure why I have this. Oh, right. Here we go. Now I can see why. A little shortcut here. You don't need this shortcut, but this is kind of cool. When you flip that bottom fraction, there's my top fraction. Here's my bottom. Flip it over. What do you notice happens here? Well, check this out. 4x cancels 4x. Maybe you can recognize that right from the beginning, because check this out. They both have the same denominator. If the denominators are the same of both of these, when you flip them, they're always going to cancel. What are you left with? You're left with 3/5. So if you run into that, that's a nice little trick sometimes. If the numbers are the same, boom, you're just left with what's on top. Fantastic, man. We cruised through that one. Try these, and then if I have some time, I'll work them out. But pause them, try them. I'm going to pop the answers up there and see you can grade them, see how you did on them. Good luck. All right, here they are for you. Notice a lot of these I had a double factor. You factor the bottom, you factor the 2 out, and then you had to actually factor it again. So double factor before it canceled. Simplifies this. Don't forget your excluded values are from the beginning, so it's both of these -5 and +5. Again, another double factor. You got to undistribute the x and then a difference of squares. So I love the double factor. Flip the second fraction and multiply when you divide. And what happened here? Complex fraction. All that thing breaks down is the 6/x. Man, that's the whole section. Good luck on the mastery check. I hope it goes well. We're going to wrap this up with a little more JJ Ice Fish. Peace out.
We called, we chained our hearts in vain. We jumped, never asking why. We kissed, I fell under your spell of love. No one could deny. Don't you ever say I just walked away. I will always want you. I can't live a lie running for my life. I came